Today, I want to talk about finding horizontal asymptotes with limits. So your first question might be, why on earth would you want to do this? We have perfectly good rules for horizontal asymptotes that make it super easy. Yes, that's true, but sometimes you might go a little while and you might forget the rules and you might not have any reference page with you and you might need a way to find horizontal asymptotes. That's what this is for, right? This should not be your primary way of doing it, but it is a way, and that's what I want to show. So let's say we have a function f of x, and let's say it's 3x squared minus 7x plus 2 divided by 2x squared plus 3x minus 9, right? And we want to find the horizontal asymptote. Well, how do we do that? Well, what does a horizontal asymptote mean? Well, it means as x approaches infinity, y will approach some specific number, right? So what do we want to do? We want to take the limit as x approaches infinity. So the limit as x approaches infinity of 3x squared minus 7x plus 2 divided by 2x squared plus 3x minus 9, right? And we can do this using L'Hopital's, but I'm sure you can already see, if you have any practice doing this, that this will end up being 3 over 2. So our horizontal asymptote will be y equals 3 over 2, or y equals 1.5, right? Now let's get rid of this, and let's try to do it with something here. Let's do it. F of x equals 3x plus 7 divided by 9x squared plus 7x minus 6, right? And once again, we want to try to find the horizontal asymptote here. Well, we take the limit as x approaches infinity, right? And we can start, well, let's use L'Hopital's this time. We'll get 3 over, and this will become 18x, and then this right here will become plus 7. So this will become 3 over infinity, which will equal 0, right? And as you can see, the horizontal asymptote being at 0 holds true for our horizontal asymptote rules, where if the power on the denominator is larger than the power on the numerator, then the horizontal asymptote will be at y equals 0, right? So this does hold true. But then, let's try to do one more, and let's see what happens if we do it when we have an oblique asymptote, right? F of x equals 7x squared minus 3x plus 2 divided by x minus 1, okay? So once again, we take the limit as x approaches infinity, right, and of 7x squared minus 3x plus 2 divided by x minus 1, right? Let's use L'Hopital's again. So this will equal the limit as x approaches infinity of, this will become 14x, that's 17, 14x minus 3, and this will become over 1, right? Well, if we try to do this, it'll just equal infinity. If you ever get a limit where it equals infinity, it doesn't necessarily mean you have an oblique asymptote, but what it does mean is it means you don't have a horizontal asymptote, okay? So if you ever try to do this and you end up with infinity, that means you do not have a horizontal asymptote. It could imply you have an oblique asymptote, but then you're going to have to remember the rule for oblique asymptote, where the power up here must be only bigger by 1 than the power down here. So in this case, we would have an oblique asymptote, but it doesn't necessarily imply it. Thank you for watching. Let me know if I say anything wrong or if you have anything additional to add. Have a great day.